All right, test 2 review. The first question is going to talk about even or odd symmetry. Remember what we talked about with even or odd symmetry. Even symmetry So when we're talking about symmetry, even symmetry means you're symmetrical with the y-axis. Here's my y-axis. So if you are the same on both sides of the y-axis, then you have even symmetry. If you are symmetrical with the origin, then you have odd symmetry. You're neither if you don't have one of those. Okay, so when you're symmetrical with the origin, that means you're symmetrical with the x and then symmetrical with the y. But here's what this graph looks like. What is that symmetrical with? What is it the same on both sides of? That y-axis, right? That y-axis, both sides are the same. And what does symmetrical with the y-axis mean? You are even. Something that would be odd would be like the x cubed graph. This is an example of odd symmetry because if I reflect across the x, then I'm here, and then reflect across the y, I would be there, right? So that's what odd symmetry looks like. That's an example of odd. But the question number 1 was an even since it was y-axis symmetry. Now, the next few problems are going to be talking about horizontal and vertical shifting. Remember what horizontal and vertical shifts mean. They come from the inside numbers give you the horizontal shift, but you go opposite the sign. So an inside plus shifts you to the left, and inside minus shifts you to the right. And then your outside numbers do your vertical shifting and go with the sign. So a plus shifts you up and a minus shifts you down. All right, so our function is g of x equals x plus 1 squared plus 4. So what's the shape or what's the graph going to start off with? Which shape are we talking about? Parabola, right? What is that going to come from? X squared. So you're going to start off with the x squared graph, and then you're going to shift it. You're going to shift it blank 1 unit. Here's my 1. What kind? It's an inside, right? Inside plus, shift you left. Then blank 4 units. So there's my outside shift, which is vertical, up or down, plus shifts you up. Now, remember when we were doing the graphing in this section in Math Lab, it was a little different, right? Just like always, you would go and tell it what shape you're starting with, which is x squared, that parabola. And then what did you do? You clicked anywhere in the graph. And what it did is it put your parabola right here at the origin. Then you came down here to your shifting box, right? And your shifting box, the first thing I need to tell it is this shift. So I'm going to shift it to the left 1 unit. So in your shifting box, you would just move it to the left 1, and that'll move you to the left 1. And then you do your vertical shift and tell it to shift you up 4. So positive 4 on your vertical shift, which left 1 up 4. And it will move your parabola to the right spot. So instead of plotting points, that's what we did in that section. We just clicked parabola and then used my shifting box to tell it where to shift. All right, number 3 is another shift. This is a square root graph. F of x equals the square root of x minus 10. Where is that minus 10? Is it inside the radical or outside? It's inside. And inside minus, she's going to shift it to the right 10. Then you're going to have a multiple choice to pick out which graph it is. They're all going to be that shape, the square root shape. They're all going to have the same range. They're, I mean, the same the hash marks, I can't think of the word I'm trying to say. The hash marks are going to go by 5s. So there's 5, there's 10 to the right. So that's where it's going to start and be your square root graph. G of x equals, number 4, g of x equals negative x minus 2 squared plus 5. It's going to start off with an x squared, right? All right, so it's going to have 3 blanks in this one. Every blank is going to give you a drop-down choice selection to choose from, okay? This first blank is going to be your horizontal shift always. So where is my horizontal shift? It's inside, which means since it's inside minus, good. It's going to be shifting it right 2. Then it's going to reflect it, right? What's reflecting it? This negative right here. It's reflecting it across the x-axis, right? Because it flips it upside down. So if I reflect, it's going to give me a drop down again. I'm reflecting across the x-axis. And then my vertical shift. Where am I shifting it? Up or down? Up 5. All right, number 5 and 6 are pretty much going to be free points because they're asking us to find the zeros of a quad equation. So if I'm asked to find the zeros of a quad equation, I can go to my quad program. Now, for those of you that don't have the quad program on your calculator, I'm going to send out a link that takes you to a web page that does the same exact thing as the quad program. Okay, so and all you have to do is know what your A, B, and C are, which are always the same numbers. A is what's in front of your squared. B is what's in front of A or X or whatever it is. And C is always your constant. Oops. So my A in front of A squared is 1. My B is in front of the A, which is 12. And my C, which is my constant, is 32. So if I go to program or use the link that I'm going to send you, go into program, down to quad, hit enter twice. And then it's going to ask you your A, B, and C. So 1, enter, 12, enter, 32, enter. And what does it tell you the solutions are, or the zeros? -4 and -8. Number 6 is same exact kind of problem. F of x equals 5x squared minus x plus 8. So again, it wants to know what your A, B, and C are. This time, what's A? 5. B, which is the number in front of x, which is -1. Your C is your constant, which is 8. So again, if you go to your quad program, type in your A, B, and C. So 5, -1, and 8. Hit enter. This time, it gives me an I solution. So I can type these all in at once, right? Tell it you want it to be a fraction, then enter your numerator. I'm going to have 1. Then how can I include both solutions without having to type in them separately? What can I use?
Plus or minus.
Good. That plus or minus that's down in your toolbox. Then on the other side, I have I square root of 159. And then down in my denominator, I have 10. Now, number 7 is one that's going to tie in solutions to a quad equation to where the x-intercepts of your parabola are, right? They are related. The x-intercepts are where it crosses the x-axis, and it's going to be the same places as the solutions to the quad equation were. So on number 7, your function is x squared minus 4x minus 5 equals 0. Yep, I'm going along with that. But then it actually gives me the graph. And points out where it's crossing the x-axis. The first thing it's actually going to ask me is, where are the x-intercepts? There's 2 of them. When you enter x-intercepts, you're talking about points, right? Points always are shown as ordered pairs. So there's going to be 2 of them. So the way you're going to enter them is 2 ordered pairs with a comma in the middle of them. And remember, what's MATLAB going to do if you don't put in that comma in the middle of the 2 points? It's going to mark it wrong. Okay. If something like that happens, just send me an email or tell me that I got this question right. I just forgot to put my comma. I don't mind giving credit for stuff like that. So each ordered pair will always have an x coordinate and a y coordinate. If you are on the x-axis here, what does that mean your y's are? Your 0, right? Because what does y being 0 mean? It means your point hasn't moved up or down. That's what's keeping it on the x-axis, is it's not moving up or down, which makes it an x-intercept. So both of the y's will be 0s. Then your x's are going to be where they cross the x-axis. This one crosses at -1, so that one's at -1, 0. This one crosses at +5, so that one will be at +5, 0. If I plug this in my quad program and get these solutions, or the zeros of this quad equation, what do you think they're going to tell me? -1 and 5. So the second part asks you for the solutions to this quad equation, which is -1 and 5. So do you see how that is related to the x-intercepts? They're the same numbers as those x coordinates. I do not put a parenthesis around this. Why do I not put a parenthesis around this? It's not representing a point on this parabola. It's telling me what the solutions to this quad equation are, right? If you put parentheses on that, you're saying there's a point at -1, 5, which there's not. Okay, so just make sure your x-intercepts are entered as ordered pairs. Your solutions are not. All right, number 8 is that problem that talks about the wire connecting to the top of an antenna tower. So if you draw that out, this is what it's going to look like, right? There's going to be an antenna tower that goes straight up and down. The wire would be slanted. So this is dealing with a right triangle, and we're going to want to know what those distances or lengths are for these 3 sides. So what theorem do we use here? We use the Pythagorean theorem that goes for right triangles that tells me what? A squared plus B squared equals C squared. Now on this, it doesn't really matter who you label A and B, but this side always has to be your what? Your C. So the story is going to tell us where to put which numbers. Okay, the first thing it says is a wire is stretched from the ground to the top of an antenna tower. The wire is 35 feet long. So if this is my wire, I already know that that's 35 feet. The height of the tower, so here's my height of my tower, is 7 feet greater than the distance from the tower's base to the end of the wall. I mean, to the end of the wire. So there's my tower, there's my base. Okay, so let's see what it tells me about that. It says find the distance, or the height of the tower is 7 feet greater than the distance of this ground. So what's this going to be? And then we'll talk about this related to this. This side is 7 feet longer than this side.
So you could do x.
I can do x here.
X plus 7.
Good. X plus 7. So now that I know that, let's set these up according to the Pythagorean theorem. So here's my A and B. So I have what? X plus 7. And what do you have to do to everybody? Square them. Plus x squared equals the C side, which is 35 squared. So let's see what we get from this. How do I find out what x plus 7 squared is? FOIL. I'm going to have to do x plus 7 times itself. And then FOIL it. My first, x times x squared. My outer, x times positive 7, positive 7x. My inside is another positive 7x. My last 7 times 7 is plus 49. What do you get if you put these x's together? 14, good. So x squared plus 14x plus 49, which goes in this spot right here. So x squared plus 14x plus 49. Bring down this, plus x squared equals 35 squared, which is 1225. Look at your left. Who can you put together on the left side of this? How many x squareds do you actually have?
2.
2 of them. So I'm putting these x squareds together. So 2x squared plus 14x plus 49 equals 1225. So now it's showing to be a quad equation, right? Because it's x squared, which means I can go to my quad program to solve it, but first everything has to be on one side and set equal to 0. So I'll know my correct A, B, and C. So I need to subtract this to turn it into 0 on both sides. So minus 1225. So there's my 0. Over here, I've got 2x squared plus 14x. When I do 49 minus 1225, I get negative 1176. So there's my A, B, and C for the quad. A is 2. B is 14, and C is negative 1176. So again, if I go to the quad program in my calculator, or using the link that I'm going to send, A, B, and C are 2, 14, and negative 1176. And it tells me 21 and negative 28 are the solutions to this quad. What is X representing up in this picture? The length from the base of the tower to the end of the wire. Who doesn't make sense here? Because of the negative, right? That negative 28. You're talking about the distance of something. It's not going to be negative feet. So this side is 21. Now here's how that does relate to this. What is 21 plus 7?
28.
28. Okay, so the two questions are: the distance from the wire to the tower is 21. The height of the tower, which is 7 feet greater than that, is 28. Number 9 is talking about an extension ladder. So the story is actually going to draw out this same shape. But you just have to be careful how you label your sides. The foot of an extension ladder is 9 feet from a wall. So here's a wall. There's the extension ladder. There's the ground. So here's my ladder. The foot of an extension ladder, so here's the foot of the extension ladder, is 9 feet from the wall. So that's telling me that this side right here is 9 feet. The height that the ladder reaches on the wall, so here's my height. And the length of the ladder are consecutive integers. So what does that mean between this side and this side? If from this side to this side are consecutive integers are just come one right after the other. So that means the height is x. And what is the length of the ladder if it's the very next number?
X plus 1.
Good. X plus 1. So your numbers are in different, the side that you know on the last problem was this side, right? This time you know this side. So just make sure you label all the sides correctly. What is my a squared? What's a? This side, which is x. Let's square it. Plus my b side, which is 9, and square it, equals my c side. What is my c side? X plus 1, and square it. So on the left side, I've got x squared plus 9 squared, which is 81, equals x plus 1 squared. So again, to find that, I'm going to need to FOIL it. So x times x gives me x squared. My outer x times 1 is 1x. Oh, hang on, my battery's good. What's my inner? Another 1x. Again, my inner is another x, and my last 1 times 1 is 1. How many x's do you really have? You've got 2, right? You've got 1 here and 1 here. So you've got x squared plus 2x plus 1, which goes right here under the x plus 1 squared. So it's showing quad again because of the x squareds, which means in order to use the quad, you have to move everything to one side to set it equal to 0. The first thing I would move would be my x squared over here with this one, which actually makes what happen? They cancel both of them out, right? Because if I subtract it here, I have to subtract it here. So that x squared and that x squared are both actually gone. So let's see, what am I left with on the left? 81. On the right, I have 2x plus 1. So I'm not quad anymore, right? I'm just trying to solve for x by isolating it, which means I need to subtract 1. So now I have 80 equals 2x. So when I divide both sides by this 2, what do I get? X equals 40, which represents this side. That's your x. The only question it's going to ask me, though, is what is the length of the ladder, which is this side. So x, which is 40, plus 1 is 41. So your only solution to the question that's being asked is that 41. It doesn't ask me what the height is. All right, number 12. 10. All right, it gives me a graph. And it gives me all this information. We're moving into the section where we did vertex, axis of symmetry, increase, decrease. maximum or minimum value. On this one, it actually gives me what the vertex is. And that's going to be what the first question is where is the vertex of this parabola? And it's an ordered pair, right? Because it's a point, and it actually tells me what the ordered pair is. It is 3, 0. This is going to ask me what's the axis of symmetry, which remember is a vertical line that goes straight through the vertex. And this one's going to say type an equation, right? Because if you're a line, you're an equation. If you're a vertical line, what is every single point on this x coordinate? 3. It's all 3. Right? Every single point on that line, the x coordinate is 3, and that's what the equation is. X equals 3. Has to be an equation. Does this one have is the vertex its minimum or maximum? It's its minimum, right? Because it's the very lowest point on the parabola. And what is the minimum value? What is value always talking about? Your y. Y's are your values. So what is the y or the minimum value? 0. When you're talking about a value, you're not talking about an equation. You're just talking about pretty much the y coordinate of that point, which is 0. Number 11. F of x equals 2x squared plus 6x plus 2. So it doesn't tell me what the vertex is, but it asks me what the vertex is. And remember how you find the x coordinate of that vertex. That's part of that quadratic formula. It's the part that's on the outside of the radical, which is the opposite of b over 2a. Right? Your a, b, and c, again, are always the same places. So what's the opposite of b would be -6 over 2 times a, which would be 2 times 2, which gives me -6 over 4, which reduces to what? -3 over 2, right? Because 2 goes into both of those, 3 times and 2 times. So there's your x coordinate of the vertex. How do you find the y? Well, if you know what the x is, doesn't this mean the same thing as y? Yeah, so I can do y equals and then replace those x's with -3/2. So I have 2. Open parenthesis, my x is -3/2, close, squared, plus 6. Open parentheses, -3/2 plus 2. Now I'm just going to go to my plain screen on my calculator. Since I don't want to do all this by myself, you can type this right here just into your plain home screen, exactly like you see it, and hit enter. So what do I have first? 2, open parentheses, -3 over 2, close them, square it, so squared button, plus 6, open parentheses, -3 over 2 again, close them, plus 2. So when I type that in, it tells me negative 2.5. Okay, so I'm going to actually enter it, talk about it both ways. So my y is negative 2.5. This part wants me to type it in as a fraction. So I just type in negative 2.5 in my calculator and then hit math, enter, enter. That turns that decimal into its fraction equivalent, which is negative 5 over 2. So negative 5 over 2 is the y coordinate of that vertex. So here's my vertex. The axis of symmetry, which is going to be what? Always a vertical line that cuts the parabola right in half, and it's going to be x equals, well, if you know the vertex, it's just the x coordinate of that vertex. So x equals negative 3 over 2. Does this parabola have a maximum or a minimum? So if it's not negative, it's going to be right. It's going to open like this, which means the vertex is going to be at the bottom of it. And what is the minimum value? Negative 5 halves, right? It's always the value is always the y coordinate. So negative 5 halves. And then it's going to say, okay, now graph it. The very first point it's going to want you to graph, once you tell it the parabola shape, your yellow instruction rectangle at the top of the graph is going to say plot the vertex. When you're plotting the vertex, you don't want to see fractions. You want to see decimals. So I already know what that one is. How do I find out what this is? Just type that into the home screen of your calculator, negative 3 divided by 2, and it's going to tell you negative 1.5, which is going to be the first point that you're going to have to plot. Now, on this, when you're moving your mouse left and right and up and down, it's always telling you where you are up in the right corner. So you need to go left 1.5, down 2.5. And this graph actually gives you hash marks that are halves. Okay, you can always use this. So left negative 1.5, down 2.5. It'll be right side up. Now, but what are you going to have to do to actually graph this? You're going to have to plot another point. So unless you want to choose x's and plug them in and solve them for y, you can go to your y equals and put that in your y equals, because what do you need? You just need to see the xy table of points on this graph, right? So if you type it in, then just hit second table, there's all the points you're going to need. And it looks like I can plot that point right there at 0. Oops. I should have plotted my point before I did that. There's another point at 0, 2. It'll plot that next point for you to be able to draw the parabola. So again, put it in your y equals, second table, and grab another point out of that XY table to draw the parabola. All right, number 12 is actually another shifting. It's just going to be a true-false statement. But if you know your shifting rules, it shouldn't be too bad. It says, determine whether this statement is true or false. The graph of h of x equals x plus 1 squared. So before we even look at the true-false part, what is the shift going to be? It's inside, so I'm going to go opposite of this. So I'm going to go left 1. That's what my shift should be. It says this can be obtained by translating the graph of h of x equals x squared right 1 unit. So is that true or false?
False.
Right. This shouldn't be right. This should be left, which makes it false. All right, we're going to try to do 2 more. Number 13 and 14 are going to ask us the same question about the function. F of x equals x squared minus 10x plus 16. The first thing it's going to ask me is where's the vertex? So I will use the opposite of b over 2a, which will give me the x coordinate. What's the opposite of b? Positive 10. 2 times a will be 2. So 10 over 2 gives me 5. So that's the x coordinate of the vertex. The y coordinate comes from just plugging in the 5s for the x's. So I have y equals 5 squared minus 10 times 5 plus 16. So let's see, I can plug that in. 25 minus 50 plus 16. So negative 25 plus 16 gives me negative 9. So there's where the vertex is. 5, negative 9. Does this one have a maximum or a minimum? How's it going to open? Right, it's going to open like this since your x squared is positive. So it's going to have a minimum value. Value always means your y coordinate. So what is your minimum value? Negative 9. Now, this is the one that's going to ask me about the range. So let's see. If your vertex is at 5, negative 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's your vertex. It opens upward. So the range is my y values. If your y value is negative 9, and that's your minimum, that means that's the lowest point of the range. Where do the numbers go up? Your y's do from here. They go infinity. So the range starts, right? Because that's the very lowest number of the range is negative 9, but then they go up forever. So I want to talk about negative 9 to infinity. What always goes around infinity?
Parentheses.
Parentheses. That's exactly right. My graph does cross through negative 9. That's why the negative 9 has a bracket around it. And then it's going to ask me, where does it increase and where does it decrease? Now, increase and decrease, always use the x coordinate of the vertex, and everybody has parentheses. Okay, so which side, what are the values doing on this side? They're decreasing until they get to the bottom, the minimum, and then what do? They increase. So my increase is this side. Where does it start to increase? No. 5, right? You always use the x. And how far does it increase? To infinity. So the increase is from 5 to infinity. The decrease is this side. Where does it start decreasing? From all forever to the left, negative infinity until it gets here, which is 5. So negative infinity to 5 is the decrease. All right, last one we're going to do today, number 14. Did it ask me all the same exact questions? Just a different function. F of x equals negative 4x squared minus 4x plus 1. So the vertex, to find the x coordinate, I'll use the opposite of b over 2a. The opposite of this b is positive 4. 2 times a, which is negative 4. So 4 over negative 8, which gives me negative 1/2 when I reduce that. So there's the x coordinate. The y. So I'm going to replace these x's with negative 1/2. So I have negative 4, open. Negative 1/2, thank you. Square, close it, square it. Minus 4, open. Negative 1/2 plus 1. So put this exactly like you see it in the plain screen of your calculator. And what does that give you? Did you get 2?
2.
Yeah. 2. So there's the vertex at negative 1/2, 2. How does this one open up? It's an upside down parabola, which means its vertex is its minimum or maximum.
Maximum.
It's its maximum because it'd be at the top. So the maximum value, what does value mean to use? Y, which is 2. So the maximum value is 2. So let's look, even though it doesn't ask us to graph it, just to help us out. So left 1/2, up 2. Be somewhere like this, right? The vertex is at negative 1/2, 2. Because now it wants to know the range. The range means what are all the y values in this function? This 2 is the very highest number in the range. So it's the end of it, right? Where is the lowest? Where does it go to? Negative infinity. So you start at negative infinity, you go to 2, you cross through 2. Yeah. Right? It does cross through that point. So you use the bracket around the 2. Increase, decrease. This time, this side is my increase, right? The values are going up. Where do they start? Negative infinity until they get to negative 1/2, which is also the same part where they start to decrease. So where are they starting to decrease?
Negative 1/2.
Negative 1/2 all the way to the right.
Infinity.
So infinity. Okay, so we'll cover the rest of it in the next class, starting with number 15.